section. I'm going to record myself going through every single question. As I do that, I'll do my explanations, I'll draw on the question. You can then go through at your own pace, figure out where you went wrong, and start your corrections. Okay, so that's what this session is for. I'm going to get straight into it. Okay, so, right, I'm going to do some calculations when I need to. I'm going to show you exactly what you should have done to get these questions right. Okay, so question 1, a geologist compares what? The volumes. Okay, please remember that you can use highlighters on the actual question. So highlight the volumes of 3 rocks. Okay, he's got 3 measuring cylinders with different volumes of water, and he places each rock into one of the measuring cylinders. The diagrams show the measuring cylinders before and after the rocks are put in. Okay. Which row shows the volumes of X, Y, and Z in order from largest to smallest? Make sure you highlight that, largest to smallest. Okay, so what you need to do here is figure out the volume of each rock by finding the difference between the 2 measuring cylinders. Okay, so this first measuring cylinder here, the meniscus is exactly at 20. This one, it's exactly at 70. That means the volume of your rock of X is 50. Okay. When you look at Y, what you see here is 25, 26. This is 27. Okay. Your volume here, 75, 76, 77, 78. Okay. When you minus those 2, you get a volume of 51. Okay. So already you know that Y is larger than X. Okay, when we read off here, the volume before is 33 in this measuring cylinder and 79 in that measuring cylinder. 79 minus 33 gives you 46. Okay, so that means Y is the biggest, followed by X, followed by Z. Okay. Y, X, Z, your answer should be B. Okay, this was a very simple, just reading measuring cylinders and finding the difference between the 2. Okay, and you want the largest to the smallest. Okay, right, question 2. Okay, the diagram shows an enlarged drawing of the end of a meter rule. It's being used to measure the length of a small feather. First thing you need to notice, millimeters. We are on the millimeters side. So you cross out C and D. Those are centimeters. We're not on the centimeter side, we're on the millimeter side. Okay, you then need to read, that's at 29, that is at 10. 29 minus 10, 19 millimeters. Okay. So make sure there's always 2 that are definitely wrong. And you cross those 2 out, and then you figure out between the other 2. Okay, 19 millimeters. Right, looking at a distance time graph. Okay, so in your head you should be thinking, distance time graph, what do I remember about distance time graph? Okay, an object moves at a constant speed, then it begins to accelerate. Okay, we are looking for the shape of this graph, a constant speed and then accelerate. Okay, it is not A, because here the distance is not changing, which means your object is not moving. Okay, here we do, this is a constant speed, yes. Okay, so that ticks the first half, but it's not B again, because now we've got this flat line. That distance is not changing, therefore my object's not moving. So it's not accelerating like it should. Okay. If you look at C, we have a constant speed because the line is straight, which then turns into a curve, which means we are accelerating. Okay. So a constant speed for some time, you have a straight line, and then a slight curve as you accelerate. It's not D. D is just acceleration straight away. Okay, so your answer for that one was C. Okay. Right, number 4. Now, again, we have a distance time graph. Okay, and it's showing how the distance traveled changes with time. Which row describes the speed of the vehicle? Okay, so from P to Q, we have a constant speed. An increasing speed means that it is accelerating. Think about it. If your speed is increasing, you are accelerating. A straight line is not acceleration. Okay, so your speed is constant. So we're either A or B. Okay. Q to R, the speed is 0. The distance is not changing, therefore it's not moving. So we're still A or B. R to S, again, is the same as P to Q. It's the same shape. So your speed is constant. Okay, not decreasing. If your speed is decreasing, you've got deceleration. You actually can't even show that. So ignore that completely. Okay, so your answer is A. You've got a constant speed, then 0 speed because it's not moving, distance is not changing, and then you have constant speed again. All right. Question 5. A stone falls freely from the top of a cliff. This is always important. Air resistance may be ignored. So in other words, this stone is like it's falling in a vacuum because they've said ignore the air resistance. Okay, you need to figure out what makes a stone fall. Gravity makes anything fall. Okay, so which graph shows how the acceleration, not the speed, how the acceleration of the stone varies with time? The acceleration does not change because acceleration due to gravity is 10 meters per second squared. Always. We're ignoring air resistance, so that stone will always feel 10 meters per second squared of acceleration. Its speed would change. If this was speed time, then something would happen. Okay? But it's acceleration versus time. Your acceleration is not changing. It's acceleration due to gravity. Okay, so that was quite a tricky one. You had to read this. Air resistance may be ignored. Okay, and I think question 6 is the same. So a heavy object is released near the surface of the earth and it falls freely. Air resistance can be ignored. Okay, how does it fall? Gravity. Okay, no air resistance. Which statement about the acceleration of the object due to gravity is correct? Acceleration due to gravity is always constant. Okay, it doesn't depend on the mass and it doesn't depend on the volume. Okay, it depends on gravity. The acceleration is constant. Okay, 10 meters per second squared. Okay, question 7. A cup contains hot liquid. Some of the liquid evaporates. In other words, you lose some liquid. What happens to the mass and what happens to the weight of the liquid? Okay, if I am losing liquid, my mass is going to decrease. Okay, so it's not C or D. If my mass decreases, my weight will also decrease. Okay, because let's say the liquid was 1 kg, that means its weight would be 10, 1 times 10. If that was to decrease to 0.5 kgs, the weight would now only be 5 newtons, 0.5 times 10. Okay, so if the mass decreases, which it does because you're losing liquid, the weight is also going to decrease. Okay, so your answer for that was A. Right, an object moves in a circle. Straight away you should be thinking, centripetal force. okay, at a constant speed. Which statement about the force needed on the object is correct? Okay, a force away from the center keeps the object moving. No. A force in the direction of motion. No. Okay, your centripetal force acts towards the center of the circle. Okay, remember, if you're moving in a circle like this, it's the centripetal force acting inwards that keeps you going in a circle. Okay, so your answer for number 8 was C. Okay, number 9, another speed time graph. A car moves with a constant speed and then a constant acceleration. Which graph is correct? Okay, so a constant speed means you have a straight line like this, a constant speed. Okay, so it's not A because we don't have that straight line first. It's not B because this is 0, so it's not even moving. Okay, C, we have a straight line, constant speed, and then we have constant acceleration. Okay, it's definitely not D. We've got deceleration and then a constant speed. Okay, so constant speed, constant acceleration. Okay, question 10 was a bit of a trick question. Okay, so it tells you that a car travels 100 kilometers and the journey takes 2 hours. Okay, the highest speed of the car is 80, the lowest speed is 40. What is the average speed for the whole journey is what they are asking. Okay, these two speeds, 80 and 40, that would have been at a specific point in time. We don't care about that. We care about for the whole journey. So in actual fact, we didn't even need to know this. Because the first sentence tells me a car travels 100 kilometers for 2 hours. Speed equals distance divided by time. The distance is 100, the time was 250 kilometers per hour. Okay, so that was quite a trick question because I think lots of you said 80 plus 40 and then you divided it by 2 to get 60. Okay, that is incorrect because that's only for one specific point. We want for the whole journey. The whole journey was 100 kilometers and it took 2 hours. So the average speed, he was going 50 kilometers an hour. Okay, so that was a bit of a trick question. You didn't actually need this last sentence at all. You could have just worked it out from 100 kilometers, 2 hours. Okay, so that question was a little bit mean and tricky, but your answer was B. Right, question 11. The diagram shows a piece of foam rubber that has air pockets. Okay, air can be squished out of things. Diagram 2 shows the same piece of foam rubber after it has been compressed so that its volume decreases. Okay, what happens to the mass and to the weight of the foam? Okay, it's certainly not going to increase the mass. Why would it increase? You're making it smaller. Okay, if there's no change in the mass, why would the weight increase? Okay, there's no change in the mass and there's no change in the weight. You're actually just compressing it. Okay, you're making it more dense, changing the density, but you're not changing the mass. Okay, if you cut a piece of the foam off, then yes, you would be changing the mass. You're just squeezing out the air. Okay, so the mass does not change, the weight does not change. Okay, right, question 12. A metal block has these dimensions, 2, 10, and 5, and it has a mass of 1,000. What is the density of the metal? Density equals mass divided by volume. Okay, so it's not A or B because that's the wrong way around. Okay, the mass is 1,000. Okay, the volume is 2 times 10 times 5. Okay, that's how you work out volume. Length, width, height. So it's 1,000 divided by 2 times 5 times 10. Okay, Your answer is D. This doesn't even make sense. Why would you times the mass by 2? Okay, mass divided by volume. Okay, question 13. 4 objects are each acted on by only 2 forces. Which object is in equilibrium? Okay, so we're looking for forces that balance each other. In A, certainly they don't balance each other. There's 2 going down, 1 going up. Okay, so we actually have 1 Newton going down. Okay, B, we've got 2 going up and 2 going down. So that must mean that B is balanced. Okay, C and D, both of these forces, if that one's going up and this one's also going like that, these are actually going to turn. Okay, D is also going to turn because you've got that 4 newtons is going clockwise. This 4 newtons is technically also going clockwise. So again, this is going to swivel. Even though the 4 and the 4 are balanced, they're going in the same direction. So you've actually got a total of 8 newtons. So your answer here was B, not D. Okay. Right, question 14. Now we're looking at a spring, so you should be thinking in your head, Hooke's law. The diagram shows the length of the spring with and without the loads attached. That is important because this length is, you're going to need it. Okay. What is the extension of the spring when the load is 400 newtons? Okay. So we've got 65 centimeters with the load. But don't forget your spring still had a distance before the load. So 65 minus 20 will give you 45 centimeters. Okay. You have to minus the original length from when you've got the load. That will give you your extension. Okay, question 15. A vehicle has a mass of 900 kgs and it's traveling at 20 meters per second. What is the momentum? This was really easy. Momentum equals mass times velocity. Okay, 900 times by 20 gives you 18,000. Okay, super simple. You should not have struggled with that at all. What is momentum? Mass times velocity. Mass is 900. Velocity is 20. 18,000. Okay. Which lists contain only scalar quantities? Okay. The best way to answer this question is go through each list, and if it has a vector, that's not your answer. Okay. So A, acceleration and force are both vectors. It's not A. Okay. B, it's not B again. You've got acceleration, force, momentum, and velocity. Those are all vectors. Okay. C, you've got distance, energy, mass, and speed. Those are all scalars. Okay. It's not D because, again, momentum and velocity are vectors. Okay, so your answer for number 16 should have been C. Okay, number 17, a student measures the length of a spring. Back to Hooke's law. Okay, she then hangs different weights from the spring and she measures their length. The table shows her results. What is the extension of the spring when the weight is 3 newtons? Okay, so when the weight is 0, her length was 520. Okay, so that's your original length of your spring because there was no weight on it. Okay, she then put the 3 newtons and it became 533. Okay, minus those 2, you get 13 millimeters. Okay, that is the extension from the 0 to the 3 newtons. Okay, which energy, number 18, which energy resource is used to generate electricity without using any moving parts? Geothermal, that moves turbines. Hydroelectric, that also moves turbines. Nuclear also moves turbines. So your answer, solar energy. Think of your solar panels and your inverter. Nothing is moving, okay? You're just getting solar energy to charge your batteries to make your inverter work. Okay, so your answer was D. Number 18 was easy. Right, number 19. A cyclist is traveling down a hill from rest. Okay, that is important. He was at rest. In other words, he wasn't moving. Okay, and he doesn't pedal. But he applies his brakes. Okay, and then he stops. So, which energy changes have taken place between X and Y? Kinetic is not first because it says he was from rest. Okay, so you cross out C and D. We then have gravitational first. He then is moving because he applies his brakes, so he has to be moving. When he applies his brakes, he's going to get friction, which would produce heat. Okay, so your answer there was A. Start with gravity pulling him down, which makes him move. He then applies his brakes, which causes friction, so you're going to get thermal or heat energy coming off. Okay. Right, number 20 was very tricky. Okay, so basically, you've got this long plank, X and Y, lying on the ground. Okay, and there is a load 0.5 meters from X. There's a load of 120. Okay, this end Y is lifted off the ground. Okay, so your bar is now going to be lifted off the ground like that. So X is going to be your pivot. Okay, your bar is flat. If my elbow is X, you're lifting it up like that. Okay, so Y is a moment that's going up. Okay, and you need 65 newtons in order to lift your plank like this. Okay, so we have to figure out, well, what is W? What you had to figure out here was that you've got two moments. You've got this moment going up, okay, which is Y. And you can work that moment out because moment is your force, which is 65, okay, times your distance from the pivot. The pivot is X, okay? So the distance is 0.5 plus 1.5, which is 2, plus another 2. So that's 4, okay? Y is 4 meters, the whole length of the bar away from X, okay? If you work that out, you get 260, okay? So that is your moment going up. That moment is going to equal this moment coming down. And the moments coming down, we actually have two of them. We've got the weight of the load here, and that's 120, and it's 0.5 meters from your pivot. Okay, so it's times by 0.5. We also have W. We don't know what W is, but we know the distance of W from X, 0.5 plus 1.5, which is 2. Okay, what you have to remember here is that it's the distance from the pivot, not the distances that they've actually given you there. So those distances are mean, they're tricking you. Okay, it's the distance from the pivot, and the pivot is X because that's what's staying on the ground. Okay, when you work all of that out, you get, this works out as 60 plus 2W. So now our moment of Y, which we worked out as 260, equals these two moments going down, which is 60 plus 2W. Okay, if you work all that out, you get 200 equals 2W, so W 100 newtons. Okay, so that was quite a long question, and you really had to think and add your distances, and always remember it's the distance from the pivot. Okay, and in this case the pivot is X. Your bar is going up like that. Okay, That was a really tricky one, but if you got that right, well done. Lots of calculations for number 20. Okay, number 21 is similar to the other question, except now we only want vector quantities. Okay, it's not A because energy is not a vector. It's not B because speed is not a vector. It's not C because, again, energy is not a vector. So it's D. Velocity has direction, force has direction, and acceleration has direction. Okay, so 21, your answer was D. Okay. Right, question 22. A gas molecule strikes the wall of a container. The molecule rebounds with the same speed. Okay, so it's going one way, hits the wall, bounces back the other way. What happens to the kinetic energy and what happens to the momentum? Okay, the kinetic energy is going to stay the same because it moves away with the same speed. Okay, kinetic energy is going to stay the same. Okay, what happens to the momentum though? When it's going towards the wall, it's going to the right. When it's going away from the wall, it's going to the left. Okay, so momentum actually changes because momentum takes into account distance. So it's going to the left in one way, or the right in one way, and the left the other way. So your direction has changed, therefore your momentum has changed, because momentum takes into account direction. Okay, so number 22, your kinetic energy stays the same because your speed stayed the same, but the momentum changed because it changed direction. Okay, so number 22 is also a bit of a trick question. Okay, 23, which diagram best represents the movement of a smoke particle? Your answer is going to be D, because remember the smoke particle hits something and then bounces off. B, it's kind of just wavy, it's not really hitting anything. And the same with C, it's kind of wavy, it's not hitting anything. It has to be D because the smoke particle hits the air particle and then bounces off completely in a different direction. Okay, so that's your answer for D. Okay, 24 is also really tricky. So we have the volume of a gas and it's being measured at different pressures. Okay, so our pressure is changing. Okay, it's either going to be going up or down or whatever. Okay, and the pressure and the volume of the gas are found to be related by this equation. Pressure times volume equals a constant. Okay, so which quantities are kept constant and which quantities are changed? Okay, the density of the gas is not going to be constant because I'm changing my pressure. Okay, pressure and volume, that could be 1. If I changed my volume, now I've got the same amount of molecules in a smaller volume, my density has changed because here it's a lot less dense than here. Okay, so my density has changed. Okay, they don't mention anything about the mass. I have not taken away any gas. If I took away some gas, then my mass would change. Okay, so my mass is staying constant. The temperature of the gas is also staying constant. They didn't tell you anything about the temperature. Okay, so what they were trying to get you to think of here is this diagram. How are volume and pressure related? Okay, if I decrease my volume, I'm increasing my pressure, and I'm changing the density of my gas because this one at the bottom is a lot more dense than that one at the top. Okay, so your density is changing, your mass and your temperature are staying constant. Okay, so that was a tricky one. Okay, last question. A container is filled with a liquid to a certain depth. The pressure of the liquid at the bottom of the container depends on several factors, okay? Which one does it not depend on? The strength of the gravitational field. It does depend on that because that is what is pulling the liquid down, okay? Gravity is pulling the liquid down, so the pressure definitely does depend on that, okay? It also definitely depends on density, okay? Remember, pressure in a liquid is height times density times G, okay? So yes, it depends on G. Yes, it depends on density. Yes, it depends on the depth of the liquid. That's the H part. So the only thing it doesn't depend on is the magnetic field of the Earth, okay? That actually has nothing to do with pressure, okay? So they were trying to get you to realize you were looking at pressure in a liquid equals height times density. That's supposed to be that funny P. Height times density times gravity, which is 10. Okay. All right. So those are your 25 multiple choice questions. You are going to go through them. You are going to go through them in your own time, go through each question and make sure you understand each question. Okay. I hope that helps you guys. Bye.